Okay. Yeah. So, um, if we want to find the pressure that is experienced at point A, how do we find that pressure? So we need to know the height of that point from the very top. Okay, so the height of the liquid that is above point A. And then we need to use a formula that is pressure at point A is equal to P naught plus rho GH. What is P naught? That is the atmospheric pressure. So this pressure on the very top from the atmosphere plus rho GH is the pressure from the liquid that is above point A. Okay, so that is it. Where did I even put equal? Yeah. Now, when a liquid is at equilibrium, the pressure is the same at any point along the same horizontal surface. So let's mention that. What do I mean by this? So obviously the pressure is increasing down, so downwards, so that the pressure is changing vertically. But what about this horizontal lines that I drew? We actually assume that, this liquid is at equilibrium. That means the pressure in the horizontally is the same, okay, at a certain level. All right. What else? Yeah, let's talk about hydraulic systems. Now, this is the only formula you need to know from liquid pressure. Are you done?
Yeah, Pooh.
Okay. So, hydraulic systems. In fact, we're going to talk about transmission of pressure in hydraulic systems. Okay, so let's draw it first. A hydraulic system, what does it look like? Okay, so these are two pistons, okay, at point 1 and point 2. This area right here, so this area, I mean, let's call it A1, and this area over here, this is A2, okay. Yeah, obviously you can see that A2 is the basically this is the area of the piston, okay, so the cross section of the piston. So obviously area 2, they actually have yeah, so obviously area 1 is smaller than area 2. So if you think about the equation of the pressure, which is pressure is equal to force by area, you can clearly see that the force that is experienced in area 2 will be higher, right? If the pressure is equal.
Yeah.
All right. So first of all, this, we have liquid inside this. This is incompressible liquid. Now, you have to know what is incompressible. Incompressible means the density of the fluid does not change. Okay, that is an incompressible liquid. Okay, let me just write it down sequentially. Now, what does it mean? Pressure can be transmitted in all directions if it is exerted on an incompressible liquid. Now, if we use an incompressible liquid inside the hydraulic system like we did over here, that means the pressure in this entire container everywhere is the same, the value of the pressure. Okay, so the force, let's say we put in a force F1, and this will push out a force F2. Okay, so if we put a small force at F1, F2 will be a very large force. Okay, so that's what happens in cars, for example. We just simply press on the brake or anything with our feet, right? And it stops a huge car like that. How does it happen? Using a hydraulic system. Like even with a small force, you're actually doing a big thing, because this force that comes out as F2, this is a large force.
But this is only for incompressible liquids, right?
Yeah, incompressible liquids. Yeah, so if they ask you what are the components of a hydraulic system, obviously you can see that this is a container with two openings, and then you have obviously two pistons, and then a press, and then obviously you have the incompressible liquid inside. Okay, so yeah, I'm going to write this down. Since A1 is pressure, then A2, the force exerted at point 1 will produce a larger force at point 2, because the pressure is the same. So pressure inside the incompressible liquid is the same. So pressure P is equal to F1 divided by A1, which is equal to F2 divided by A2. Okay. I hope that's clear.
Force in one, as you said, um, the force exerted at point one, it produces more because of the area, right? Because for pressure is inversely proportional to area.
Exactly, because the area is larger, but the pressure is constant.
Yeah.
And not inversely proportional, it is actually proportional.
Oh, all right.
Yeah, because pressure is inversely proportional, but force is directly proportional. So let me give you an example to make it clear. Let's say a force 2 Newton is exerted at point 1. So let's say the area A1 is 10 meters square and area A2 is 40 meters square. Find F2. So how would you find it? So let's try to find the pressure first, pressure that is in the incompressible liquid. So that is F1 divided by A1. F is 2 Newton. A1 is 10 meters square. So that is what? 1 by 5. What is 1 by 5? 0 0.25. 0 0.2. Right? Wow, I'm so bad at math. Yeah, obviously it's 0. Okay. Okay. So that is Pascal, let's say. Now the pressure is obviously constant. So if we want to find F2, that is going to be pressure times A2. So pressure is 0.2 Pascal times A2 is 40 meters square. So that gives us 8 Pascal. 8 Newton. So initially we only put 2 Newton at F1, but it is producing 8 Newton because, yeah, the area is 4 times. So that's why the force is also 4 times.
I'm done copying.
Okay. Yeah. I hope that's clear.
Yeah.
Okay, the one last point is that thus we can use hydraulic system to lift heavy objects. Okay, now we can move on to atmospheric pressure, how to find it and what is it. Um, Now, what is atmospheric pressure? It is the force per unit area exerted against a surface by the weight of air above that surface. Okay, so basically everything is actually experiencing an atmospheric pressure. Okay, now how do we measure this atmospheric pressure? Now, the instrument that is used to measure atmospheric pressure is called a mercury barometer. So if we want to sort of draw this, this is mercury reservoir. And we have vacuum over here. This is a thick glass tube. Yeah, so that's it. So we have this height h above this. That's what a mercury barometer looks like. Now, at sea level, typically the height h is 760 millimeters. That is usually the number that we memorize. So at sea level, the h is found to be 760 millimeters. Yeah, so atmospheric pressure is typically recorded as 760 millimeter of mercury. Okay. Now, even if that thick glass tube is tilted, like slightly tilted or whatever, h, that height, will still remain the same. Okay.
So
Unless it
the
is,
pressure will also remain the same, right?
sorry.
If the height remains the same, even if it's tilted, the atomic pressure will also be the same, right?
Exactly, the atmospheric pressure will be the same. Yeah, but the atmospheric pressure, that means the h, the height of the mercury, it will actually change only if this barometer is brought to a different level, to a, let's say, not at sea level, probably at a higher altitude or something like that, where the atmospheric pressure is different. Only then you will see that the h, the height of the mercury, will change. Okay, so this is a point. Even if the tube is tilted, h will remain the same unless the instrument is brought to a different level where the atmospheric pressure is different. Now, if you want to know why are we corresponding this h as the atmospheric pressure, because obviously, as you can imagine, the air is exerting a pressure on this tray, let's say, of mercury. So obviously, some of the mercury will go up, and depending how much the pressure is, this will go either, a lot of mercury will go up, or it could be here because the pressure is less. But I mean, it really depends on the value of the atmospheric pressure. Okay.
Yeah.
All right. Now, what else? I think you also need to learn manometers. Mm-hmm. Oh, are you done with the previous one?
Yeah, Ponda.
So it is another instrument to measure gas pressure. Okay. Now, even for gas pressure, like liquid pressure, you have to use the formula rho GH, because actually for any fluid, it's the same formula, rho GH, not just for liquid, even for gas. So what does a typical manometer look like? It looks like, let's say, like this. So you have hollow tube, which is open on one side and obviously open on both sides. Basically, you have a liquid inside this tube. Let's say this is a liquid of density rho. Okay. How do you measure pressure from this instrument? Okay. Let's say some gas is exerting pressure from this side. So this is gas pressure P1. And let's say there's nothing on this side, just the atmospheric pressure. So this is P0, the atmospheric pressure. So now we need to know the height, the difference of the height of this liquid on both sides. So let's say this is the level. So this right here is H. Now you simply use the formula rho GH. So if you want to know P1, that is going to be P0, which is the atmospheric pressure, plus rho GH. That's it. All right.
Yeah.
I think I covered everything on syllabus. Please cross-check and ask me anything if you have any questions, just ask me.
Apu, in number two, they said, explain how pressure varies with force and area in the context of everyday examples. So should we like know some examples?
Explain how pressure varies with force and area in the context of everyday examples. Okay. For example, let's think about something. Mm, yeah. Yeah, let's think about heels and yeah, walking on sand, wearing heels and wearing flip-flops. Okay. So which one is easier? Obviously, if you walk on sand wearing flip-flops, right? Because why? Obviously, let's say a flip-flop. Yeah. Now it has a big surface area, right? This entire surface area that is falling on the sand. So the pressure of your body putting on the sand, the force, so that's your weight. Now it is being put on this entire surface area, um, okay, on the sand. So that's why the pressure, if you try to calculate it, let's say your weight is um, 580 Newton. And let's say, yeah, the area of the flip flop, I would just approximate it with both feet is, let's say, yeah, 20 meters square or something. Find out the value.
It's 29.
Yeah, let's say that is 29 Pascal. Now, when you're wearing, let's say, heels, so what does a heel look like that, hopefully. Okay. The only area that is in contact with the sand is this much. That is a very small area.
Yeah.
The force of your body, I mean, the weight of your body, it's still the same. So if you try to calculate the pressure, it's still 580 Newton, but the area is smaller. Let's say it's half of the flip-flop. And what do you get?
58.
58 Pascal. That is so much higher than this one. So obviously it is going to be harder to walk on sand wearing heels, because these heels will, put pressure on the sand and it will go down, right? So balir bhitere ঢুকে ঢুকে যাবে. This is one of the examples that I can think of. Yeah, maybe you can come up with another example. I don't know.
Can't think of anything as of right now.
Yeah, me neither. Yeah, this is probably the most classic one.
Yeah.
I
I
don't know.
had another question. I think you described it already, but the question in the syllabus, or what they're asking to describe it, really sounds really complicated. It says describe how a change in volume of a fixed mass of a gas at constant temperature is caused by a change in pressure applied to the gas.
Which point?
It's number H, 7H.
Describe how a change in volume of a fixed mass of gas at constant temperature is caused by a change in pressure applied to a gas. Yeah. Now, the thing is, gas is definitely compressible, right? So just let me give you a good example. Let's say I'm coming up with this experiment myself. It's not scripted anywhere, just so that you understand what they mean. Let's say I've stuck a balloon to a syringe. Okay. So obviously, if I put pressure, a certain force to this syringe and push it down, all these gas, there will be a pressure due to this gas moving into this balloon, right? And this balloon will not stay the same. It will obviously expand, right?
Yeah.
Yeah, so that's what they mean about gases. When you apply pressure, when you apply certain force, they are going to get there is going to be a change in volume of the gas. Okay. Now I'm assuming that the temperature inside the balloon is constant. Why? Because if the temperature is increasing inside the volume inside the balloon, then the volume would change even more, because at higher temperature gases expand even more. Okay. Obviously, if the temperature is decreasing inside the balloon, then the volume will itself decrease inside the volume inside the balloon. That's just one of the factors
For
that
gas, in order to find the volume or pressure of gas, we need to use the P1V1 formula, right?
Oh, yeah, 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 yeah. So the P1 V1 formula, you would, yeah, you would definitely use that. Yes.
But that's just for gas only, like the P1 V1 formula.
Yeah,
Can't
yeah.
use
Usually,
the other.
u- usually we do that for gases
Mhm.
because that's what changes its volume when we apply pressure.
I think everything's covered.
Okay, I'll be back in just a moment. Okay, hello.
Yeah, cool.
Yeah, are there any more questions or
No.
anything left? Okay, great. Yeah, should we move